When upgrading electrical service, specifically in the context of increasing the amperage to 200 amps, a common question arises regarding the necessity of upgrading all existing 220 volts wiring to a 4-wire configuration. The straightforward answer is no. Not all 220 volt wiring throughout the building needs to be immediately upgraded simply because the main service amperage is being increased. The primary focus of the upgrade centers on the service entrance conductors, which are the wires that run from the utility meter to the main electrical panel. These conductors are responsible for carrying the entire electrical load for the building, and therefore, they must be appropriately sized to handle the increased amperage of the upgraded service. This typically necessitates a change to a 4-wire system. This 4-wire system generally comprises 2 hot wires, a neutral wire, and a ground wire. The 2 hot wires provide the 240 volts used for appliances like electric ranges, dryers, and air conditioning units. The neutral wire provides a return path for the 120 volt circuits that power lights, outlets, and smaller appliances. The ground wire provides a safety path for electrical faults, helping to prevent electric shock. The National Electrical Code, or NEC, outlines the specific requirements for service entrance conductors based on the amperage rating of the service. For a 200 amp service, the NEC typically requires a minimum wire gauge for the service entrance conductors. This gauge is determined by the conductor material, such as copper or aluminum, and the insulation type. Electricians use NEC tables, such as Table 310.15. V16 to determine the appropriate wire size based on the ampacity requirement. However, the wiring within the building, the branch circuits that feed individual appliances and outlets, are generally not required to be upgraded unless they are being used for a new purpose that demands more amperage than the existing wiring can safely handle. For example, if a homeowner is installing a new electric vehicle charging station that requires a dedicated 50 amp circuit, the existing wiring from the panel to the location of the charging station would need to be upgraded to meet the increased amperage demand. This would involve replacing the existing wire with a larger gauge wire that is rated for 50 amps, as well as installing a new 50 amp circuit breaker in the electrical panel. Similarly, if an existing 220 volt circuit is being repurposed to power a larger appliance, such as a new hot tub or a larger air conditioning unit, the wiring may need to be upgraded to handle the increased load. However, if the existing 220 volt circuits are already properly sized for the appliances they serve, there is generally no need to upgrade them simply because the main service amperage is being increased. It is important to note that the NEC requires all electrical work to be performed in a safe and workmanlike manner. This includes ensuring that all wiring is properly sized for the intended load, that all connections are secure, and that all grounding is properly installed. When upgrading electrical service, it is always best to consult with a qualified electrician who can assess the existing wiring and determine whether any upgrades are necessary. The electrician will also ensure that the upgrade is performed in accordance with all applicable codes and regulations. Factors influencing wiring upgrade necessity: 1. The existing wire gauge. The gauge, or thickness, of the existing wiring is a primary factor. If the current wiring is already adequately sized to handle the existing and potential future loads, it may not require an upgrade. Electrical wiring has ampacity ratings, which specify the maximum current it can safely carry. These ratings are based on the wire's material, insulation type, and installation method. The NEC provides tables that list the ampacity of various wire sizes. For example, copper wire with type THHN insulation has different ampacity ratings depending on its gauge. A 12-gauge copper wire with THHN insulation might be rated for 20 amps, while a 10-gauge wire might be rated for 30 amps. 2. The intended load increase. If the service upgrade is intended to support new appliances or increased electrical demand, the existing wiring must be evaluated to ensure it can handle the additional load. This evaluation should include a load calculation, which estimates the total electrical demand of the building. The load calculation takes into account the size and type of appliances, the square footage of the building, and other factors. The NEC provides guidelines for performing load calculations. For example, the the NEC specifies a minimum load calculation for general lighting and receptacle circuits based on the square footage of the building. It also provides specific load calculations for appliances such as ranges, dryers, and air conditioning units. 3. Code compliance. Local electrical codes and the NEC may have specific requirements for wiring upgrades based on the scope of the service upgrade. These codes are designed to ensure electrical safety and may require upgrades even if the existing wiring appears to be adequate. The NEC is updated every 3 years, and local jurisdictions may adopt the latest version of the code or modify it to meet local needs. It is important to consult with a qualified electrician to ensure that all electrical work complies with the applicable codes. 4. Safety considerations. Even if the existing wiring meets minimum code requirements, upgrading it may be advisable for enhanced safety and reliability. Older wiring may have deteriorated insulation or loose connections, which can increase the risk of electrical fires. Upgrading to newer wiring with improved insulation and connection methods can reduce these risks. Ground fault circuit interrupters, or GFCIs, are another safety feature that can be added to electrical circuits to protect against electric shock. GFCIs are required in certain locations, such as bathrooms and kitchens, and may be advisable in other areas as well. 5. Future-proofing. Consider future electrical needs when evaluating wiring upgrades. Upgrading wiring to a higher capacity than currently required can provide flexibility for future expansion or the addition of new appliances. This can save time and money in the long run by avoiding the need for future upgrades. For example, a homeowner who is planning to install an electric vehicle charging station in the future may want to upgrade the wiring to the garage to a higher amperage rating than is currently required. 6. Condition of existing wiring. The age, material, and condition of the existing wiring play a crucial role. Older aluminum wiring, for instance, may require special consideration or replacement due to potential fire hazards. Aluminum wiring was commonly used in homes built in the 1960s and 1970s. However, it has been found to be more prone to loosening at connections, which can lead to overheating and fires. If aluminum wiring is present, it is important to have it inspected by a qualified electrician and take appropriate measures to mitigate the risks. This may include replacing the aluminum wiring with copper wiring or installing special connectors that are designed for use with aluminum wiring. 7. Panel capacity. Ensure the existing electrical panel has sufficient capacity to accommodate the new service and any additional circuits. If the panel is full or outdated, it may need to be replaced or upgraded. The electrical panel is the central distribution point for electricity in the building. It contains circuit breakers that protect each circuit from overloads. If the panel is full, there is no room to add new circuits. If the panel is outdated, it may not have the capacity to handle the increased electrical demand of the upgraded service. In these cases, the panel will need to be replaced or upgraded. Considerations for specific scenarios. 1. Electric vehicle charging. If installing an electric vehicle charger, a dedicated circuit with appropriate amperage is necessary. This often requires new wiring from the panel to the charging location. Electric vehicle chargers can draw significant amounts of current, typically ranging from 16 amps to 80 amps. Therefore, it is important to install a dedicated circuit with the appropriate amperage to handle the load. The NEC provides specific requirements for electric vehicle charging circuits. These requirements include the size of the wiring, the type of overcurrent protection, and the grounding requirements. 2. Kitchen renovations. Kitchen renovations frequently involve new appliances that may require dedicated circuits or increased amperage. Evaluate the existing wiring to ensure it meets the demands of the new appliances. Common kitchen appliances that may require dedicated circuits include refrigerators, dishwashers, microwave ovens, and garbage disposals. The NEC specifies the minimum number of circuits required for kitchens based on the size of the kitchen and the types of appliances that are installed. 3. Additions or extensions. Adding new rooms or extensions to a building will necessitate new wiring that complies with current codes and meets the electrical demands of the new space. New wiring must be installed in accordance with the NEC and local codes. This includes using the correct wire size, installing the correct type of overcurrent protection, and properly grounding the wiring. It is important to consult with a qualified electrician to ensure that all new wiring is installed safely and correctly. In summary, while a 200 amp service upgrade doesn't automatically mandate rewiring the entire building, a comprehensive assessment of existing wiring, anticipated loads, code requirements, and safety considerations is essential. Consulting with a qualified electrician is paramount to ensure a safe and compliant electrical system. The electrician will perform a thorough inspection of the existing wiring, assess the electrical loads, and determine whether any upgrades are necessary. They will also ensure that all work is performed in accordance with the NEC and local codes. Remember, safety is the top priority when dealing with electricity. Always hire a qualified electrician to perform any electrical work. Attempting to perform electrical work yourself can be dangerous and may violate local codes. The cost of hiring an electrician is well worth it to ensure the safety of yourself and your family. The NEC serves as a comprehensive guide for safe electrical installations. It is updated every 3 years to reflect the latest technological advancements and safety practices. Local jurisdictions may adopt the NEC or modify it to meet local needs. It is important to be familiar with the NEC and any local amendments to ensure that all electrical work complies with the applicable codes. Here are some additional points to consider when upgrading electrical service. 1. Permits. Electrical work often requires permits from the local building department. Obtain the necessary permits before starting any work. Permits ensure that the work is inspected and meets code requirements. 2. Inspections after the work is completed. Schedule an inspection with the local building department to ensure that the work meets code requirements. Inspections help to identify any potential safety hazards and ensure that the work is performed correctly. 3. Documentation. Keep records of all electrical work, including permits, inspections, and invoices. This documentation can be useful for future reference and may be required when selling the building. 4. Insurance. Inform your insurance company of any electrical upgrades. This may affect your insurance premiums. 5. Future needs. Plan for future electrical needs when upgrading the service. This may include adding extra circuits or increasing the size of the panel. 6. Energy efficiency. Consider energy efficient appliances and lighting when upgrading the service. This can help to reduce your energy consumption and save money on your electricity bill. 7. Surge protection. Install surge protection devices to protect your electronic equipment from power surges. Surge protection devices can help to prevent damage to your electronic equipment caused by lightning strikes or other power surges. 8. Grounding. Ensure that the electrical system is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to prevent electric shock. 9. Arc fault. Circuit interrupters or size. Install size in bedrooms and other areas to protect against arc faults. Arc faults are a common cause of electrical fires. A size detect arc faults and trip the circuit breaker, which helps to prevent fires. 10. Smoke detectors. Ensure that smoke detectors are properly installed and maintained. Smoke detectors provide an early warning of a fire, which can save lives. By carefully considering these factors and consulting with a qualified electrician, it is possible to upgrade electrical service safely and effectively.